So friends, welcome back to a new session. So in this video, we are discussing about how to find the integral of tan raised to nx dx, or its formula, which is defined as in the form of tan raised to n minus 1x divided by n minus 1 minus integral of tan raised to n minus 2x dx. So this is the reduction formula for the integral of tan raised to nx dx here. So by the proof, or we want to find how this formula, which is equal to the solution for integral of tan raised to nx dx here. By the proof, in the LHS we can write integral of tan raised to nx dx as in the form of integral of tan raised to n minus 2x into tan square x dx by solving this term, which is also equal to the previous given term. Then in the next step we want to do that. Here a term existing as in the form of tan square x. So here we can use the trigonometric identity, that is sec square x minus tan square x, which is equal to 1. So from here we can find what is tan square x is, which is equal to sec square x minus 1. Then substituting this value here, then it become integral of tan raised to n minus 2x into sec square x minus 1 with the dx also. By opening this bracket, then it become integral of tan raised to n minus 2x into sec square x minus tan raised to n minus 2x with the dx also. So by solving this thing, then it become in the next from this expansion, by opening this bracket here, then applying integral dx with each term here, then it become integral of tan raised to n minus 2x into sec square x dx minus integral of tan raised to n minus 2x dx here. And note here that we want to change this term, that is we want to reduce the first term here and doesn't change the second term. That is by taking the first term, that is this as the first term and these are the second one. Then in the first term we can change as by taking the first term integral of tan raised to n minus 2x into sec square x dx. And note here that put a substitution here and find a proper solution for this term here. It means that put a t is equal to, that is the substitution, t is equal to tan x. Then find dt divided by dx, that is the derivative of the t. Then it become tan x divided by dx. Then it become the derivative of tan x, which is equal to sec square x. Then the value for dx, which become dt divided by sec square x here. Then by substituting this term as in this formula, then we can get a final solution as in the form of integral of tan raised to n minus 2x. Put tan is equal to t here, that is t raised to n minus 2 into sec square x into dx. The value for dx, which is this term, that is dt divided by sec square x here. Then by cancelling this term, then finally we can get a term as integral of t raised to n minus 2 dt here. So it means that which is equal to t raised to n minus 2 plus 1 divided by n minus 2 plus 1 plus c. Then it become t raised to n minus 1 divided by n minus 1. So here we expand, that is integral of tan raised to n minus 2 dt by using the formula as integral of x raised to n dx. Integral of x raised to n dx, which is equal to x raised to n plus 1 divided by n plus 1. So by using that formula we get a proper solution finally as in the form of t raised to n minus 1 divided by n minus 1 here. So now we can replace the first term as in the form of t raised to n minus 1 divided by n minus 1. We know what is t is. T is equal to tan x, that is tan raised to n minus 1x divided by n minus 1. Then the second term, that is this term, put here, that is integral of tan raised to n minus 2x dx. So now here we get a solution, that is tan raised to n minus 1x divided by n minus 1 minus integral of tan raised to n minus 2x dx. So here integral of tan raised to nx dx, which is equal to tan raised to n minus 1x divided by n minus 1 minus integral of tan raised to n minus 2x into dx. So this is the reduction formula for the tan function here with its nth integral. So let's wind up this session and see you soon with a new video with more information and more mathematical content. So don't forget to subscribe our channel for more informational videos. Stay tuned with us.